So, going to heat up the ends of the cases again to drop the gear shafts back in. 2 gear shafts have got to go in together. Right, so we've been heating that up, it should be warm enough, so now we're going to start putting the shafts back in. Don't forget that these baffle plates have got to go in first, and also you've got to have one of the selector forks on the gear train, and then we've got to put the 2 sets of gears together and lower it down over the shaft, and hopefully it will drop in like that. So that's in. This 3rd shaft can go in like that, and that's the gear train all assembled. What I do now is I'll just give it a little gentle tap, make sure it's seated, and we can carry on assembling the gearbox. Okay, action. Right, we're going to put the selector forks back in. So shaft can come out. Just sitting there like that, and it can go back in there. Now what we've got to do is, with these ends of the selector forks, these lugs here, here and here, have got to go into these cam plate slots. So, and that sometimes means that you've got to lift up the selector forks as you do it to get them in position. So just putting them up, can be a little bit fiddly. Right, so roughly in the right position, and now I've got to upend the gearbox and put those special bolts back in. Remember, these bolts are shouldered bolts, so you can't use ordinary 8mm bolts as a replacement. And they've got to be torqued up with the torque wrench. I'm just going to torque up these selector fault cam bracket mounting bolts, and they're torqued up to 19 Newton meters on this particular model, but it may be different. There is another torque wrench setting for other models, so make sure you've got the right one. This is action. What we're going to do now is start setting up the inflow of the gearbox. You can see that I've already fitted the gasket, and it's a good idea to do that so you don't need to take into consideration the thickness of the gasket paper when you're doing your calculations. Okay, so we've got to put the measuring plate on now, and that just slips over. So what I'm going to do is take some bearing extension measurements now, and to do that, give myself up a little chart which I'm just going to fill in as I take the measurements. So when you see me writing stuff down, that's what I'm going to be doing. So the first thing I did was I measured the thickness of this plate, so as I know the thickness of that, and that's 7.5 mil. The other thing I know what the bearing clearance should be, which with new bearings it should be 0.1 millimeters, a tenth of a mil. If they are old bearings that you're putting back in, then the clearance should be smaller, and it should be 0.05 of a mil. So that's that. The rest of the data we've got to actually measure and put in. So first thing I'm going to do is start measuring the bearing extension measurements, and I'm going to take several measurements. I'm going to keep going around the bearings and take several measurements until I'm happy that I'm getting a reasonably good average, because this is can be slightly fiddly little thing to do. So we've got the input shaft here, the intermediate shaft here, and the output shaft here. And I'm going to go around and I'm going to take several measurements and see how they start to compare. I might not go as far as taking 6 measurements, I just made provision for that. Okay, so to do that I need my I need this gauge here. Make sure that the gauge zeroes properly before you start using it. Always make sure your gauge is zeroing properly before you start using it, and get a good feel for the gauge. You can adjust these. I'm actually getting 0.02 of a mil error on this, so I'm going to just make a note of that rather than adjust it for the camera, because it takes a little while to adjust the gauge. So I've got plus 0.02 error there. So as long as we take that into consideration, we know once we've made the measurements. Alright, so I'm going to start off with the input shaft, and I'm just going to rest the gauge across the bearing. Okay, make sure it's only resting on the bearing, and I'm going to measure the distance down to the surface of the plate. So when you're taking these readings, you need quite a light touch, and it'll take quite a bit of practice probably before you start to get some consistent readings. Make sure that you've got the plunger of the measuring gauge as close to the bearing as possible, but don't actually have it touching the bearings. Remember, when using any micrometer, it takes quite a bit of practice to get it right, so if you get frustrated, put it down, walk away, have a cup of tea, come back and have another go later on. And don't give up. And that's reading 6.65 millimeters. So input shaft 6.65. I'm going to go and take a reading now from somewhere else on the bearing. And again we're getting a reading of 6.65 again. So we're getting fairly consistent readings, which is good. I'll just take another reading off the bearing. There will be a certain amount of movement in these bearings. They can rock a wee bit, so that's why I take a reading in several different places, and I just take an average of the measurements that I'm getting. So I'm just taking one more measurement of the input shaft here. Notice how I'm working the thimble of the micrometer backwards and forwards very lightly, and just getting a very light touch down of the plunger coming out at the end of the micrometer. I find this works best, so if you turn it too much then you start to lift the whole micrometer up. So you've got to have a very light touch and take your time. And this way you get the best, most consistent and successful results. So we're looking at 6.7. Okay, so that's enough for that one. So now I'm going to move on and do the counter shaft. So this is the counter shaft here, and we're going to take again a similar number of readings. So our first reading is 6.73. Next one is 6.74.